Hello students, welcome to Siddapur Mathematics Academy. So in today's class, I am giving you very interesting and important concept of the mathematics, that is the calculus, in that 5th chapter, continuity and differentiability. See, the students are waiting for this video, I know that. Here in today's class, I am giving you very interesting and important concept, but in a very simple way. So if you watch the video, then only come to know how much simple I made it. Here, continuity already students are studied in the 11th class, correct or not? In the first PUC already the students are studied. But the maximum students complaint is what? No ma'am, we are not following that continuity. So please once again explain. So before moving to that exercise, whatever it is, I will explain the concept once again. Suppose one function is, one work you are doing. One work is doing and you are doing, go on continuing without taking a break. Suppose somewhere if we take a middle break, at that time we are not doing a work in that time period. You are doing a work continuously or not, you have took some break in between. And after some break you are go on continuing the work. So where you not did that work, at that time we are calling the work is not continuous. The work is not continuous. And this point is called point of discontinuity. That means at that certain point we are not doing the work. Suppose in the college all the classes are moving smoothly. In between somewhere if you have a gap, that means one class the sir is absent or he took a leave like that. At that time you don't have that class. After that the again class are going. At this time, if this time period the class is not took, that means it is a break. So at that time we are calling it is a discontinuous. See, if you draw the graph without any break, if you draw the curve like this here, whatever the curve, see, saw this curve, this is x-axis, this is y-axis. Saw the curve, observe this correctly. See, is it in from this end to this end, is any break you are observing? No, the curve is goes on continuing. So this is called, the function is continuous. And if I take a point x is equal to 3, you know how to draw the line for this, graph for this. X is equal to 3 is a straight line. It is a parallel to y-axis, correct or what? See, this is y-axis and this is x-axis. 1, 2, 3. Here also 1, 2, 3. These are positive values. These are negative, correct or not? So x is equal to 3 is a line, this line. Wherever you want you can move up to that infinity. So but there is no break when you are drawing the line. So x is equal to 3. This we are calling as a constant or what? Yes, the constant. X is equal to 3 is a constant. So if you draw the line, there is no break. That means this is a continuous. And if you draw like this, y is equal to 2. There is also no break, it goes on continuing. Not only positive values, even though for negative also you are drawing a line and there is no break in between. That means these points we are calling as a constant. That gives you one more hint. That means constant function is always continuous. See, I will explain one more equation. If y is equal to x plus 5. If y is equal to x plus 5, what is y power 1? X power 1. Is it a linear equation or what? Linear equation gives you the straight line. See, if you make a table, if x is 0, y is 5. If x is 1, y is 6. If x is 2, y is 7. If x is minus 1, y is 4. If x is minus 2, y is 3. Now I am marking these points here. Minus 1, minus 2, minus 3. This is minus 1, minus 2. This is 1, 2, 3, 4, 7, like this. 1, 2, 3, 4, 5, 6, 7. It goes on continuing. Mark. X is 0, y is 5 here. X is 1, y is 6. X is 2, y is 7. Next. X is minus 1, y is 4. Next, x is minus 2, y is 3. When you join this, you will get a line. So I did a mistake here. You will get a line. The line again goes on continuing. So that means there is no break in between the line, in between the graph. Suppose in some example, the line may discontinue. There is a gap. After that again it goes on continuous. So where it is not joined, where it is not goes on continuing, at that point we are calling it as a discontinuous. But students, now the question arises, for every example, is it possible to draw the graph and check whether the function is continuous? You know that if the curve goes on continuing, we are saying the function is continuous. But it is not possible to draw the graph and to check all the points every time. That's why we are calculating this. To calculate whether the function is continuous or what. Now understood. So what is the continuity? In simple, leave that mathematics on the side. In the simple word, if any work goes on continuing without any disturbance, without any break, the function is called continuous function. That only we are applying to the mathematics, that is algebraic function, logarithmic function, exponential function, trigonometric functions. See, suppose if you take y is equal to sin x, you are familiar with the graph. For sin x, the graph is like this. Up and down, it goes on continuing. So y is equal to sin x we are calling as a continuous function. So this is with the help of graph. Now the question comes, how to study this with the problem, with the calculations. So we are checking for algebraic, polynomial function, trigonometric functions, exponential function, logarithmic functions. So now let us start. How to check whether the function is continuous. I am giving you the points here. Here. A function f is continuous at any point x is equal to a. And students, for a PUC second year, the question is asked for calculation method, not to the graphical. So that they will not ask to draw the graph. Just I explain with the help of graph because to make the concept clear. See, the function is said to be continuous means these points should be important. F is defined because sometimes you are not getting sometimes here. If it is x square minus 4 upon x minus 2, in place of x is equal to 2, if you write, you are getting 0 by 0. See, 0 by 0 means you cannot write 0 by 0 as a 0, or you cannot write it as a 1, or you cannot write as a infinity. That means 0 by 0 is not defined. So this is not possible. That's why I am writing here. F is defined. Defined means you are getting some certain definite value at every point on an open interval. Open interval means, suppose for example like this. Second one, limit f of x as x tends to a exists. So I will explain this point also. Then limit f of x as x tends to a is equal to f of a. See, limit f of x as x tends to a exists. This we are, in some problem, this we are doing from left side and right side. That means, here one I am giving you one example. Y is equal to x square. If you draw the graph, you will get y is equal to x square like this. Right on the table. X and y value. If x is 0, y is 0. Yes. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is x-axis, this is y-axis. If x is 1, y is 1. If x is minus 1, y is 1. If x is 2, y is 4. If x is minus 2, at that time also it is 4. So mark this. If x is 1, y is 1. If x is minus 1, yes, the curve is like this. Here, when you check it at from this part, that is called as the, that we are calling is as the left side, from the left side. And if you check from this, from here to here, we are calling it as a right side. Suppose, so when you check this, you have to check whether the limit, left hand limit. So left hand limit, how you write? Left hand limit is, suppose at the point x is equal to a, limit f of x as x tends to a minus that above that minus sign tells you are moving from left side, LHL, and you have to calculate RHL. They must exist, and right hand limit is what? Limit f of x as x tends to a plus. If they are exist and both are equal, left hand limit and right hand limit are equal, and they are also equal to f of a. They are also equal to f of a, then we are calling it as the function is, the limit exists. The limit exists. And if the limit exists, then we are moving for the this one. If this condition is satisfied, then we are calling the function is continuous. Okay. Don't worry, they will not ask the graph in the theory paper or in the CET also. Directly you can draw. Next, when the function is continuous, this is about at x is equal to a. And we are going for a function is continuous in the open interval. A function f is said to be continuous. Now whatever the points I am giving, just please note down the students. They are very important for your theory as well as CET. The function f is said to be continuous in an open interval a comma b if f of x is continuous at each point and each and every point of a comma b. For example, if you take 1 and 2, and it should be continuous in for these 2 points, in between these 2 points, not these end points. You know that already. Open means we are not taking the end points. It should be continuous on these, in between these 2 points. So that we are calling it as it is a continuous in an open interval. Next important point. A function f of x is said to be continuous in closed interval a comma b if, first point, it is continuous in open interval a comma b. Second one, limit f of x tends to a plus is equal to f of a, right, continuous at x is equal to a. If you know only basic concept, it is enough. And you have to remember this point because this we are using when we are doing application of derivatives. That is the mean value theorem and Rolle's theorem. Next, limit f of x as x tends to b minus is equal to f of b. Left continuous function. So this is about a continuity in the closed interval at x is equal to b. Now I am giving you some important concept for your theory as well as competitive. Please note down that points. See, if you take y is equal to x plus 2, you know that this is a polynomial function and it is nothing but it is a linear equation. If you take a quadratic, it is a cubic, whatever. All the polynomial functions are continuous. See, somewhere we are using these results directly because if you write the reason, if it is a polynomial, directly you can write that the function is continuous because it is a polynomial function. For that you have to be familiar what is a polynomial function. Polynomial functions are continuous everywhere. Continuous everywhere. This concept you are studied in the first PUC, polynomial. It may contain a linear equation, quadratic equation, cubic, and next onwards they are called as a polynomial function. Next. Please note down this. Sin x, cos x, mod x. The trigonometric functions are continuous in their domain. Are also continuous everywhere. In that trigonometric terms, they are continuous in their domain. Tan x is all trigonometric. Remember that, continuous everywhere except odd multiples of pi by 2. And logarithmic functions. Logarithmic functions is also continuous. You can write it is a log function, so it is continuous in the interval 0, infinity. Log x is continuous. In the question, if it comes directly, you can write log x is a continuous function because it is a logarithmic function. Continuous is in 0, infinity. Next, power function. What is a power function? For example, f of x is equal to x raised to n, where n is positive integer. Understood? So this is also a continuous function. And all the trigonometric functions are continuous functions. Next, exponential and logarithmic. Logarithmic already I would give exponential. Exponential functions like a raised to x, they are continuous where a is greater than 0. Then rational functions are also continuous. Now the question comes, what is a rational function? So for example, f of x upon g of x. F of x is a polynomial, g of x is a polynomial. They are a continuous. F of x and g of x both are continuous, but one thing you have to remember, g of x is not equal to 0. Why not equal to 0? If it is equal to 0 means you will get the infinity. The function is not defined. So these are the important points you have to remember. Again, I am giving you some important properties before moving to the examples, exercise. properties of continuous functions. Here F and G are continuous functions. If two functions are continuous, means first one, their addition F plus G is also continuous function. Also continuous function. Second one, their subtraction F minus G is also continuous function. Third one, their product F into G is also a continuous function. Fourth one, their quotient F upon G is also a continuous function. Fifth one, K into F, where K is a constant, or K into G, because F and G both are continuous. K into F or K into G are also continuous functions. Or also continuous functions. Now, are you remembered the composite functions? Yes, students, where you are studied, where you heard that word composite functions? Yes, when you are doing a first year relations and function F of G or G of F. In the second year also first chapter, F of G or G of F. These functions, or this the another way of representation is like this. These are called composite functions. These composite functions are also continuous functions. So these are the important properties you have to remember about the continuity. Now I am moving to the example. Before going to the exercise 5.1, I will give some questions to make you perfect. I will give some questions in the continuity. For continuity, if you are familiar with limit, then it is easy. Limits already were studied in the first year. So first question, check the continuity of the function F given by F of x is equal to 2x plus 3 at x is equal to 3. Yes, students, here when you see the question, just remember whatever I explained in the today's class. In the important points I gave, every polynomial function is a continuous function. So even though point is given, can you write it as like this? 2x plus 3 is a polynomial function, therefore it is a continuous. So you can write it in two methods. One method is like this. First I am writing the function f of x is equal to 2x plus 3 and I am calculating at the point 3. That is 9. And I am calculating the limit. Limit f of x as x tends to 3. That means f of x is replacing by 2x plus 3, and after writing this, now when you are writing the value of x, when you are substituting at that time, don't write limit. Write down that value. That is 9. So then what you are writing? Therefore, limit f of x as x tends to 3 is equal to f of 3. That is 9. Hence, f is continuous at x is equal to 3. Or you also write, you can write like this. Or if you are familiar or whatever the functions you have studied in the first year text, algebraic functions, polynomial function, constant function, exponential function. So here f of x is equal to 2x plus 3 is continuous function because or since it is a polynomial function. It is a polynomial function. See why I am explaining two methods, because when you compare your notes with many of your friends, they are from different institutions and they are writing this one, and if you are writing this, and don't argue with them. These two both are equal, so please note down both, but don't mix them. You can write this one or this one. If it is a 1 mark question, write like this: f of x is equal to 2x plus 3, a polynomial function, therefore it is continuous. Shall I give you the next one? Because in some questions we cannot write directly, we have to go for the calculations. That's why I am showing you both the methods. F of x is equal to x square at x is equal to 0. So without calculations also directly the students can say, see, is it a continuous function or what? Yes. What the answer? Yes, it is a continuous. Why? F of x is equal to x square is a polynomial function, and every polynomial function is a continuous. F of x is equal to x square is continuous because it is a polynomial function. Therefore, it is continuous at x is equal to 0 also. Or one more method is what? F of x is equal to x square. So what is f of 0? F of 0 is 0. And see limit f of x as x tends to 0 is limit. Now I am writing that function value x tends to 0. In the next step, in place of x I am writing 0. At that time don't write the limit. See here, limit f of x as x tends to 0 is equal to f of 0. Both are equal to 0. Hence f is continuous function. See, student, is it very simple or what? Yes, this is very simple. And in some example, we have to calculate, we have to find left hand limit and right hand limit. Remember, in all the example, it is not necessary. If one value is given and one point without any condition, it is given at only one point, directly go by this method. Now I am showing you one more example. There we have to move to the left hand limit and right hand limit. That means if the function is defined at x is less than 0, x is greater than 0, like that. That means it is defined for left side and right side. At that time we have to calculate left hand limit and right hand limit. So I have started with very simple examples. Still I have not started the 5.1. Discuss the continuity of the function f given by f of x is equal to mod x and x is equal to 0. Now the students can ask the question. Here also only point is given how we can calculate left hand limit and right hand limit. Here mod is given. Say students, have you remembered the definition of modulus? By definition, what is the definition of modulus? F of, if it is a modulus, f of x is equal to mod x. See, mod x is nothing but minus x if x is less than 0, and it is 0 if x is equal to 0. and it is a positive if x is greater than 0. See, now the function is defined for left side and right side. See, it is less than 0, greater than 0. If the problem is defined like this, only in that time we have to find left hand limit and right hand limit. Clearly, the function is defined at x is equal to 0. And what is f of 0? Here f of 0 is 0. Now calculate left hand limit. See, in these three, in which expression it is less than 0, that we have to take as a left hand limit. And this we are marking like this, x tends to 0 minus. That above minus tells you we are writing a left hand limit. So it is a limit. F of x means what we are writing? Minus x. Now don't write 0 raised to minus because already we took the function. Now wherever x is there, write down 0. And remember, for 0 we are not writing any positive or negative value. Then right hand limit. Limit f of x as x tends to 0 plus. This 0 plus tells you we have to take the greater value. So which is greater than 0? Here x is greater than 0 is in third one. Limit x as x tends to 0. Now the answer is 0. After that we have to calculate f of 0 value. What is f of 0? So out of these three, where it is equal to 0, if x is equal to 0, the value is 0. Now compare all these three. First one, the value is defined, the function is defined, and the second one, left, we are calculated the left hand limit. So how you took the left hand? We are calculating at x is equal to 0, means in these three expressions where it is less than 0, that is left hand limit. Where it is greater than 0, that is right hand limit. So here left hand limit, right hand limit and f of 0, all the three are equal. If all the three are equal means what is your conclusion? The function is continuous. So LHL is equal to RHL is equal to f of 0. Therefore, the function is f is continuous at x is equal to 0. Now, shall I give you one question? So, fourth one I will give you as an assignment. So, in the next class I will explain this one. Then I will start with the exercise 5.1. Show that the function f given by f of x is equal to x square plus 3 if x is not equal to 0 and one if x is equal to 0 is not continuous at x is equal to 0. See student, this is the assignment question and I am giving you a hint. Here don't calculate left hand limit and right hand limit because the problem is not explained in the less than or greater than form. It is not equal to form. That means calculate limit f of x as x tends to 0 and f of 0. Compare these two. If both the results are correct, then it is a continuous. Otherwise, it is not a continuous. In the next class, I will explain this. Then I will start with 5.1.
Yeah.